As you know from your readings, Python is a language built into the QGIS user interface. In our lab, we'll see how to use this language in QGIS to create functions we can use that are not part of the core GIS package, but that we may need. This lecture is a brief overview of Python as a general-purpose programming language. It will cover the important topics in the Python tutorial. Python is backed by Google and is one of the leading languages used in computer science. One of its principal advantages is that it is multi-paradigm. It can be used as a scripting language, a functional language, and an object-oriented language. And of course we see here there's two versions, version 2 and version 3. Both of them are widely used. A block is a set of language instructions that you want to do an action on. You might only want to execute a block of instructions if some condition is true, or you might want to perform a block repetitively until some condition is met. Indentation in Python matters to the meaning of the code. Block structures are indicated by indentation. All general-purpose programming languages support repetition and conditionals. The if statement is a conditional construct in Python, and with an if statement, a block of code is executed once if a condition is true. While and for loops are repetition constructs in Python. A block of code will be executed many times depending on some condition. Indentation indicates the block of code that is controlled by if, for, and while statements. Notice that at the end of conditional and repetition statements there is a colon. This marks the end of that statement. The use of the colon to mark the end of a statement is not generally used by ordinary statements, but is used by conditional and repetition statements. We can store multiple items in a variable called a list. We use an index to retrieve these items. The first item in a list has an index value of 0. If a list has n items in it, then n-1 is the index for the last item in the list. Let's take a look at this in Python. So here we see an operation that uses a for loop to loop through a list. And the list consists of 4 tuples, or matched pairs. The first tuple is A1, second B2, and so on. We do a for loop and say we want to get each one of those tuples out of this list. The list again is denoted by brackets on either side. So the tuple by parens, so we say for xy in this list, just print out the x part of it. And that's why we get A, B, C, and D. Let's take a look at the indexing, starting with a 0. So here we made a list of simple integers. Again, the list is denoted by the brackets on either side, and we've got 9, and the commas indicate new elements in the list. So 9 is the first element in the list, and we use the index value of 0 to retrieve the first element in the list. There are 3 items in the list, so we would use 3 minus 1 as our index, or 2, to get the last item. And we see we get our last item there. There's a few very valuable methods or functions that one can use with a list. So for example, when we have a list, we can then do an append which adds something to the end of the list. And we can also use a pop to get one of the items out of the list, the item indicated by its index value, in this case 1. A list have a ability to incorporate something known as nesting. A nested list is a list composed of other lists. So here we have my list, and we see the outer brackets indicate that it's a list, and then of course the commas separate items in the list, but the first item in the list is another list, and it's got simple integers in it. So if we print out the second element, which is denoted by a 1 in my list, we get the list 4, 5, 6. If we use 2 indices to get to an item, we would get the first indices goes to the outer list elements, so it would be this 4, 5, 6, and then the 2 is going to indicate the value in the inner list, so 0, 1, 2, and we get a 6 out. We can iterate through a list, and iterate means we go through every element in the list using a for loop. And Python has structures that make it very easy to do this. So once we have a list, we just say for some list item variable name that we want to have, and list item right here is just what we give it. We could have called it Z or Y or whatever. In my list, colon, and then we print it. So this will go through every element in our list and it will print it out. And we can do that for nested list by using nested for statements. The first or outer for statement gets the outer elements in the list. And if each one of those is a list, then we can say use an inner for loop to loop through each of the individual integers in each one of the inner lists. Let's take a look at that in code. So we've got our list. Let's append an item to the list. We'll append a 6. And you see that now we have 9, 10, 11, and 6 in our list. Now let's make a nested list. And then we'll print the first item. Well, we'll print the second item, the 4, 5, 6. And you see that it prints out the item, which is itself a list. And so we get a list out. If we add a second index to it. So now we've got two indexes. The first is for the outer set of lists, and the second is for the inner set of lists. And we get a 6 there. And here we see the use of a for statement to loop through the elements in our list. We can also use a nested for statement. And then we get each individual element in the list. There's a built-in functions a function that'll give you a list of numbers called range. And so you can make a counting loop with a range, and you start with the first element and then you go up to, but not including, the last element. So let's take a look at this in our code. We see that we go from 0, the starting element in our list, to 9. We don't include the last element. That just says stop before you get to this one. So for loops are good for iterating over lists, and also in situations where we want to count something and we know the count in advance. And if we don't have those two conditions, we will generally use a while loop. That's going to be for more complicated repetition structures. Functions are blocks of code that we give names to, and that we can use that name later somewhere else to perform that particular action. In other words, the action that's performed by executing that block of code. And we usually do that because we're going to be doing that particular operation many times, and rather than repeat it every time we want to use it, we write it once, give it a name, and then just call that name thereafter. So here's the way we would call a function. We've got some function name, and we're going to pass it some arguments. This is data that we want the function to operate on. The function will do its work, and then it will return a result value. And the result value is going to be what we will take from the function and continue on with our processing. Here's how we make a function. Def is the keyword we use in Python to assign a name to a block of code. The next element is going to be max, and that's going to be the name of the function in this particular case. We could have called it add, or we could have, add numbers or multiply numbers, or any other name. Here we're going to just get the maximum value in a list, so we decided to call it max. Then in parens we're going to give it a set of arguments. So here we're going to send in a list, because we want to find the maximum value in that particular list. And then we see a block of code inside the function, and we first assign a list to the first element, a max to the first element in the list. Then we loop through every element in the list. We do a conditional check. If the item that we get looping through is greater than our current max, then we change our current max to equal that item. Then we're finished with this for loop. What we have in max is then the maximum value of the list, and that's what we return as a value. And let's take a look at this in code as well. So here we've declared our function max, and we return, after we go through our computations, we return the maximum value and also the starting value. And so I will print out the maximum value, and we see that 789 is the maximum value in my list, and we see that there. So this is our definition of the function here. And then here we call max and we send it a parameter, which is of course this my list that we have been working with in previous examples. And as we just saw, Python can return multiple values if you want it to. Strings are another type of variable in addition to integers and floating point numbers. Strings are also widely used, and Python has a wide set of string functions that we can use to do things. We can send everything to capital letters, we can send everything to lowercase, we can pick a substring out of a string. We can find if a string has certain set of characters in it, and so on. And here's all of the various string functions that were in the tutorial. They're just here as a reference for you. So in addition to list, we have some other useful built-in types. Tuples are immutable collections of objects, in other words, or elements. You cannot change a tuple once it's been made. So here we see an example of a tuple. We use the parens, and we have elements 1, 2, 3 in it, and we are going to then assign that to the variable a. We access values in a tuple the same as we would a list. The only difference is we can't change the tuple, whereas we saw we could change the list by adding items to it, and we could also change individual elements if we wanted to. A set is another useful built-in data type, and it's an unordered collection of elements where each element must be unique. So in a list, we can actually have duplicate elements. In other words, two different elements have the same value. With a set, any attempt to add duplicate values is ignored. So that can be useful for helping us find the unique values in a list. Let's take a look at a set in operation. So here we create a list. My list is now 1, 2, 3, 1, 2, 3. Let's just verify that. So you can see we've got duplicate elements in our list. 1 is duplicated, 2 is duplicated, and 3 is duplicated. However, when we use the set function to convert the list into a set, we get rid of those. So we'll go my set 2, and we get rid of the duplicates. so we're left with only the unique values. So a list is something that maps an index to a value. And it automatically creates the index for us, and the index is a set of integers that starts at 0. So it implicitly defines the keys for us. In other words, a key is something we use to retrieve a value. So the key for getting A would be 0. The key for getting B is 1, and the key for getting C is 2. In other words, key is just another name for the index that we want. So index value of 0 gives us A. There are times, though, when that can be rather cumbersome, and we want to give actual names. We want to have flexibility in how we name our index. So a dictionary lets us use whatever kind of keys we want. Instead of having 1 correspond to B in the previous example, we can have a string, for example, that's meaningful to us correspond to B. So we could have things like, here was our list before, 0 is mapped to A, 1 is mapped to B, 2 is mapped to C, and we can change it. Hello is a key that we use to map to A. 1 we map to B still, and we have 3.3 that maps to C. A dictionary lets us define whatever we want for the index value. And here we see a dictionary in action. So a dictionary, instead of being denoted with brackets as a list, is denoted by curly braces. And so we create an empty dictionary, as we see here, no elements in it, and then we can add a key, and we do that by using the my dictionary, and then we say the key we want, and then we assign something to it. And then likewise 1, assign something to it, and then likewise 3.3 and assign something to it. Then when we use one of these keys, for example hello, it will print out A. So let's take a look at this one too in code. And if we print out my dictionary, we see that we have the key 1 and its value is B. The second key is hello, its value is A, and the third key is 3.3 and its value is 3. So here's how we would use a dictionary in a real world type problem. Let's say we have a group of university students and we're storing their grades. So a student's grades for a semester will be a list of grades from each one of the courses they took. The student is going to have a name. So we assign max to a string variable called student, and we assign a list of their grades to a variable called grades, which holds that list. Now we can set it up so that if we know the student's name, we can easily look up their grades. To do that, we use a dictionary because we want to use max as a key, or the student's name, whatever it would happen to be, as a key. And of course, we can't do that with a list. We need a dictionary for that. So we create a dictionary, and it's empty. Then we used student as a key in that dictionary. So grade dictionary, the key student. In this case, student has the value max, and we assign grades to that particular key as the value. Now if we access grade max, we'll get Max's grades back out. And let's take a look at this. Oh. Let's try this again and use apostrophes. So here we assign a string with apostrophes around it to a variable student. We assign that student's grades to a variable called grades, create a dictionary, use the student's name as the key and their grades as the value that we assign. And in our dictionary we see we have Max as the name, and then here's the list of grades for Max. And we can also look at grade dictionary and just say Max, and it would give us just the list back. So a dictionary is a very powerful tool in Python because it allows us to use JSON data structures that are going to be returned by most of the modern functions that you'll be accessing on the internet. JSON is a data structure that is used for sending data back to calling programs who make calls to things like social media or surveys or other things that may be online. And a lot of times in GIS you'll get a JSON-like structure back as well. So a dictionary in Python is what we would use to represent this JSON structure. So when we make calls to these useful items out on the internet, we're going to get them returned to us as a dictionary. They're JSON structures, but they are returned to our Python program as a dictionary. Okay, well this concludes our brief introduction into Python as a general purpose programming language. We'll next take a look at how we use it inside of QGIS. But I thought first it would be a good idea just to get a general overview of Python before we look at how Python is used in our GIS package. Thank you.